In this video, I'd like to talk about the zero product property. And the concept is fairly simple. So if we had a product, let's say we have just two letters, A times B. And A and B can be anything. We'll just assume that they're variables. They can take on any value that we want. And the general idea with the zero product property is that if you have a product and one of these terms is zero, then the entire product is equal to zero. So if A is 0, 0 times B is 0. Or if B is 0, A times 0 is also 0. So when one of these terms in the product, or I should say one of these factors in this product, is 0, then it makes the entire product 0. It doesn't even matter what the other one is. So in this case, when A was 0, it doesn't matter what B is. B could be any possible number out there, but 0 times anything is 0. So we're going to use this idea to solve problems like this, or essentially to deal with quadratics or later on polynomials. So let me rewrite this. We have x plus 6 times minus x plus 1, and this is equal to 0. So the zero product property says that if one of these terms is 0, then the entire equation is equal to 0. So this entire left-hand side would reduce to 0, because you'd have 0 times something, which is 0. So we need to figure out which x value makes this expression 0. And in this case, you can probably guess it that it would be x is negative 6, because if you plug in negative 6 here, you get minus 6 plus 6, and then over here you get the opposite of minus 6, so that's positive 6, plus 1. And notice that this would reduce to 0. So you get 0 times 7, and 0 times anything is 0. So it doesn't matter what we plug in over here or what this simplifies to. As long as one of them is equal to 0, then the entire equation is equal to 0. So we can usually find as many solutions as there are factors here. So this is one factor, this is a second factor. And when you deal with polynomials, you might even have a third, a fourth, or a fifth. So maybe like even an x plus 2 term out here. But for quadratics, you're just going to have two of these. And however many factors there are, that's how many solutions there are. So in this case, we have two of these factors, two of these binomials multiplied together. And so there will be two solutions. Now we found one of them. So we need to ask ourselves, what value of x can we put in here such that this expression in parentheses would be equal to 0. And if you're not sure, if you don't want to guess your way to the answer, there's always a very straightforward way to solve this. In fact, all you have to do is set the entire expression equal to 0. And you could have done that here. Say x plus 6 equals 0, subtract 6 on each side, and you get x is minus 6. We'll do the same thing for this one. You have minus x plus 1, and we'll just say this has to be 0. And then subtract 1 on each side, you get minus x equals minus 1. Multiply everything by negative 1, and you just get x is 1. But this, again, should make sense, because if you plug in 1 here, you get minus 1 plus 1, which is 0. And it doesn't matter that this is 7, because 0 times anything is 0. So we found our two answers. The lesser value is the more negative one, or in this case, just the negative one. So that would be minus 6. And the greater value would be 1. So let's keep going with these. You just need a lot of practice to feel comfortable with them. And I'm going to rewrite this as 2x plus 4, 3x minus 2, both in parentheses, equals 0. And like I said from the previous problem, if one of these is 0, then it makes the entire equation 0. And we're going to follow that same method above, where we're just going to set this equal to 0. Now you could try and guess your way to the answer. Maybe for this one you might be able to guess that it's 2/3 because the 3's cancel there and you get 2 minus 2, which is 0. But until you feel comfortable doing that, what I would recommend is just the straightforward way of solving this. Just say that this entire expression here is 0 and then solve. So subtract 4 on each side, you get 2x is minus 4. Divide by 2, you get minus 4 over 2, which is negative 2. And you can check it. If you plug in negative 2 here, you get minus 4 plus 4, which is 0. So this is one of our solutions. Now to find the second solution, we'll set that one equal to 0. So 3x minus 2 is 0. Add 2 to the other side, you get 3x is 2. And divide by 3 to get x is 2/3, which is what you can also find by guessing once you get more comfortable with these. So now putting it into the boxes, the negative one would be the lesser one, so minus 2 there. And the greater one is the positive one, so that would be 2/3. We'll do a couple more of these. And with all of these, I'm just going to rewrite it. So g of x is minus 5x minus 1 times 2x plus 8. And this one's a slightly different problem, but ultimately it's the exact same process for solving it. So they want us to find the zeros of the function. So when they ask for the zeros of the function, they're asking which x values would make g of x equal to 0. So that's what they mean by zeros of the function. So we're going to set this equation equal to 0. So 0 is minus 5x minus 1 times 2x plus 8. And by setting it equal to 0, we can find the x values that make the function equal to 0. And those x values are what we call the zeros of the function. So we'll follow the same procedure as last time, since if either of these is equal to 0, then the entire equation is equal to 0. So I'll do this first one. We'll just set it equal to 0 and then solve. So add 1 to each side, you get minus 5x is 1. And divide by minus 5, you get x is minus 1/5. So that's this one. If you plug in minus 1/5 here, so negatives cancel, the 5's cancel, and you just get 1 minus 1, which is 0. So that one works. We checked it. When we plug it in, you do get 0 here, and it doesn't matter what this is because 0 times anything is 0. Now, this one right here, we're going to do the same thing. 2x plus 8, we're going to set it equal to 0. So subtract 8 on each side, you get 2x is minus 8, and divide by 2, you get x is minus 4. So if we plug that in to check it, 2 times minus 4 would be minus 8, and minus 8 plus 8 gives you 0. So both of these worked, and the lesser one is the more negative one. So in this case, minus 4. So we'll put minus 4 there, and minus 1/5 there. So let's do just one more of these. And very similar to the last ones, we have x plus 1 in parentheses times 3x plus 4 in parentheses, all equal to 0. And we know if one of these is equal to 0, then the entire equation is 0. So we're going to set each of these equal to 0 individually. So I'll do this one in blue. Let's say x plus 1 equals 0, and then we solve. So subtract 1 on each side, and you get minus 1. Now, these expressions where the coefficient on x is 1, these tend to be a lot easier to just guess. You can probably just visually see that if you put in negative 1, it makes the expression equal to 0. So with those, if you feel comfortable with it, you don't have to do this step because it's really only a one-step equation. But until you do feel comfortable guessing, you probably should just do this straightforward method. Now, 3x plus 4, that one's hard to guess. It'd have to be negative. You'd have to have a 3 in the denominator, so those cancel. And then you have to have a 4 up top, so you get minus 4 plus 4 equals 0. So minus 4/3 would work. You can guess your way to that answer, or until you're there, or until you're ready for that, just set the expression equal to 0. Subtract 4 on each side, so 3x is minus 4. And divide by 3, so you get minus 4/3, which is the answer that I suggested when guessing. But let's check it. So if you put that in, the 3's cancel, so you just get minus 4 plus 4, which is 0. So we checked both of these. They both made sense. And the one that is lesser is the bigger negative number. So that would be minus 4/3, since this is really just minus 1 1/3. So it's slightly bigger than this one. So you'd put minus 4/3 into that box and minus 1 into that one.